Welcome, everyone, to today's JUMP Academic webinar, Teaching Exploratory Data Analysis with JUMP. I'm JUMP Academic Ambassador Ross Matusalam, just the host today, and our presenter, whom many of you probably know, is Academic Ambassador Kevin Pochner. So where we're coming from with today's webinar is that we recognize statistics education is incorporating more and more realistic data analysis exercises, where instead of clean data sets and simple predetermined analyses, we may be asking students to take a more realistic data set and explore it graphically and statistically to better understand the nature and quality of the data, to uncover patterns that can be found there, and to determine what questions the data might even be able to answer. All while using whatever graphs or analyses are necessary to answer those questions. And these kinds of exploratory exercises might better reflect some of the challenges of analyzing data in the real world that students are going to encounter when they get out there in their careers. JUMP is, of course, a strong tool for data exploration thanks to its point-and-click and interactive interface. And with this webinar today, Kevin's going to show us how to use JUMP to incorporate more exploratory data analysis into our teaching. Before we get going, I do want to point everyone to the Q&A panel in Zoom. Please ask any questions you have throughout today's webinar. I'm going to be in there answering questions as we go along, and Kevin will pause at a couple points to take questions from the audience as well, so maybe we can see some additional things live. Please do use that Q&A instead of the chat to ask your questions. It just helps us stay a little more organized on our end and keep track of what questions have been asked and answered already. So with that, Kevin, are you there?
Yes, I am. Thanks, Ross, for the introduction.
Right. Great. Feel free to take it away.
Okay, perfect. So what I want to focus on today, and Ross set this up perfectly, is sort of getting you to think about how to prepare students for what they're going to see when they actually go out there. I remember, I guess
Kevin?
it's about 30 years ago now.
Kevin, real quick, are you sharing your screen?
Oh, no, not yet, not yet.
Oh, okay,
Sorry about it.
No,
I'm actually trying to open up a folder while we're talking.
Sure.
And this has sort of surprised me a bit when I went out to first start working 30 years ago, which is you're so used to the academic classroom setting where you're doing very defined problems, right? Let's do a one-factor analysis of variance to see if there's a difference between some response and a factor, or build a regression model showing relationships. But when you get out there and start working, it's very different than that. They're often just very vague instructions. So what I'm going to do in just a moment here, I'm going to share my screen. I'm just trying to find one particular data set to start with. Hold on one second, I'll get there. Here we go. All right. And can you just confirm, Ross, you can see my screen?
Yep, we are good to go.
Okay, perfect, thanks. Okay, so this data set is from a bank running a little campaign to see if customers might be interested in refinancing their mortgage. And what they did is they went out and called their customer. So a representative is actually making a specific call and saying, hey, are you interested in refinancing your mortgage? And obviously what they're trying to do is to figure out who are those people, who are their customers most interested in refinancing. And so they have information about each of these customers. So for example, so each row is a customer. And so, for example, well, there's going to be a balance still on the mortgage, right? So a little mortgage principal there. There's maybe an interest rate. They may know information like things like, oh, the customer's debt to income ratio, or at least they did at the time they originally applied for the loan, their age, and then there's this variable called engagement, and it's just a measure of that they know how much this particular customer is engaged with their finances. Okay, so ideally it's a yes or no answer, right? Yes, they're interested in refinancing, or no, they're not. But if we look at this column, and I don't know if any of you are familiar with this, but in the upper left of the data table, you'll see this little, it's like a little bar chart or histogram on its side. Well, if you click on that, it actually opens up these things called column headers. And so what's nice about it is it gives us actually some high level information. This first one just an account number, so that doesn't really matter. In fact, that's nominal, not a continuous variable. So it actually made more sense for me to turn it into that. Notice how many categories we have for refinancing. I'm going to do another graph in a second where you'll see more. For numeric variables like mortgage principal, interest rate, debt to income, it's showing us a histogram and then the lowest and highest value. Now, again, I'm going to make a graph in a second that's going to make this more obvious, but you should already see some strange things going on. So, for example, do you think somebody really has an interest rate of 39.3% for a mortgage? Obviously not. Just someone, same thing, the debt to income, these are meant to be a fraction or a ratio between 0 and 1, and here someone says 41.1, and then noticing all these categories. But I'm going to get a better view of this. I just like to show this, these column headers we have. I love these. I almost always have them open. Well, one thing that's nice is you can actually click on, in this case, I'm clicking on categories, and it highlights all that data. So for example, if I wanted to grab, in this case, a particular age, I can highlight that. All that data is highlighted. I can do something like, oh, maybe I want to hide and exclude those rows, or maybe I want to subset that data. So what's nice about these column headers is not just getting a summary of the variable, but you can actually interact with this as well. But what I want to do instead is I'm going to launch JUMP's distribution platform. So this is where you do any kind of univariate analysis. And so what I'm going to do is I'm going to put the refinance. I'm going to do everything but the account number. Now I've got a mix of categorical variables and continuous numeric variables. I click OK. And so I'm going to get this report. And what JUMP is going to do is, if it's a categorical variable, like this first one here, refinance, interest rate is another one. Sorry, not interest rate. Age and engagement are the ones, and then interest rate, debt to income, and mortgage principals are numeric continuous. Okay, so if it's categorical like refinance, you're going to get a little bar chart, and you're going to get a table displaying counts and proportions of those different categories. If it's a numerical variable like mortgage principal, you're getting a histogram, a box plot, some summary statistics, even a confidence interval for the mean. So if you started with this, and I almost make this graph instantly. Whenever I have a set of data, I'm like, can I just summarize it just so I can get my head around the data set? This is where you start to see the issues. And so the first one is noticing how many categories there are, right? Because these are people typing this in some kind of spreadsheet or however they're keeping track. So question mark, double question mark, triple question mark, somebody wrote don't know, follow up needed. You can see all those categories. We certainly have yeses and nos. Now the question is, what do we do about these other things? We'll talk about that in a second. Here's that interest rate one where there's this value way out here. Well, these are supposed to be, if you think of what interest rates are, clearly 39.3 isn't an interest rate on a mortgage. Maybe it's 3.93 and there was just an error in bringing in the data. And same thing, debt to income. These are not supposed to be numbers like this. It's supposed to be between 0 and 1. And so we need to fix these values here. And the other ones look pretty good. Okay, so what can JUMP do for this? And then so I used to think when I was teaching a long time ago that, oh, students can't handle giving them this messy situation. But if you can set this up, then students can often make a decent attempt at cleaning this up. So you can decide, for example, that is the interest rate. Oh, I didn't need to actually close that and bring that back up. We'll highlight this interest rate one right here, and that is row, there it is. That's row 194. And then what do? And someone might say, oh, maybe that's supposed to be 3.93, but you don't really know that, but that's a legitimate guess. But students might say, well, you know what? I don't know what that is, so I'm going to exclude that row. And you can certainly highlight that. And JUMP what's nice about this is JUMP makes all of this very easy. So I can grab that row if I want and say rows, hide and exclude, or I could go rows, delete, but I want to keep it there. This is a nice way that I can just hide it from analyses if I want. Same thing, I can go to these debt to income ratios. I'm going to highlight those. I'm going to go find where they are. There's a couple here. So the question is, should this be 0.18, not 18.8? And it could be just that was recorded wrong. Same thing. Should that be 0.22 or recorded wrong? So you can sort of guide your students on, okay, what would be a legitimate thing to do? Maybe they want to just hide and exclude it. So we're going to add some more rows in this data table that we're not going to include. So you see that symbol right there. That's basically telling JMP when you run an analysis, don't include those rows. The refinance one, we see all of these categories. Now, what I'm going to do is I'm going to go under, well, this way. I'm going to highlight the column and I'm going to click recode. Now, let's look at this for a moment. I don't think it takes a lot of effort to figure out what some of these things are. So, for example, I'm assuming the question marks, whether you put 1, 2, or 3 question marks, maybe that's also a maybe, don't know, unknown. What is X? Well, maybe that's an unknown. So it's not unreasonable for me to grab this and say, group these. And so you see how it just grouped all of those, and then I can give it some name. Now it's picking a default maybe, but I could pick something else if I want. So I'm going to call that maybe. And then same thing with these follow-ups. Do I want to treat that different than maybe? Or actually maybe I want to put them all together, and I can, same thing, here's another one, here's another one. So you can set this up to be messy, but in such a way that maybe it's not hard to make a decent attempt. And so that's kind of what I'm doing here. Oh, now there's obvious ones like N and no. Well, I'll group those together. Y and yes, I can group those together. I can decide maybe I want to hide and exclude the ones I don't know. It's all sorts of things you could do there. But I think it's a good idea to give students some exposure to dealing with some data that needs a little bit of cleanup, just to get their head around that concept. And I think you can set it up in a way that's not hard to make some reasonable guesses, whether it's, in this case, I'm recoding, or you decide to exclude some rows from the analysis because you're unclear what you should do. Now, I'm not going to analyze this particular data set. I just wanted to show you an example of something I've done before that addresses giving a data set that needs a little bit of fixing. But before I go and move on to a different data set with some analyses, Ross, let me just check to see if anyone's asking anything specific about that recoding I just showed. I don't see one in the Q&A, so I guess we're probably good.
It looks like we're good for now.
Okay. All right, let me close that one up. Okay. So this first data set I'm going to open is data from a semiconductor application. So basically what this data set is, and I'm going to start off by just showing an image, and I'll show in a moment how I made this image, but I just want to show you this so you understand what the data is about. So basically we have data collected on 48 semiconductor wafers. And there are 2 categorical variables that describes the location of the wafer within this manufacturing process. So I've got wafer position and then run number. So you can think of a manufacturing process. You know, these wafers are going along in a row, and then as you're manufacturing, you can sample along the way. So that's basically what's happening. There's 48 wafers, but there's a position and a run number. I'm gonna show you how I made this graph in a moment. And then there are 3 response variables. It's not important to talk about what they specifically are. Just think there's some kind of, let's say, an electrical property of these wafers that's being measured, or some reflective property, just something that's being measured on many different spots on this wafer. And so I'm just calling it Y1, Y2, Y3. Okay. Well, one way you could kind of set this up is explore the variability, right? That's sort of the task. Take a look at this data, create a variety of visualizations to explore the variation. So I'm not asking a specific one, like do a 1 factor ANOVA to see if this is different than this. Just explore the variability, which I had a professor in college many decades ago that sort of used to summarize that's what statistics is. Statistics is the science of studying variation, because if there was no variation, there'd be no subject of statistics. That's literally what it is. And you can do that graphically and visually. So what I'm going to do is, well, let's start off with that same univariate analysis distribution. And what I'm going to do is I'm going to put those 3 response variables, y1, y2, y3, click OK. And I'm just summarizing these in a univariate sense. And a few things should jump out. The first thing is obviously that there's this bimodal distribution for this variable y1, and y2 and y3 sort of have a unimodal shape, but we can look at that amount of variation. We get some summary statistics. So obviously you're hoping your students see this feature right away. This, what's going on here. Now let's see if we can explore the data more graphically to see if we can understand what that is. And I'm going to, let's see, what's a good chart? Oh, I'm going to open up a chart here first, just so you can see. I'm going to, this is the chart I'm going to make here. Now that one happens to be, where was that one? Variability attribute gauge multivariate chart. Now I'm going to put just one response in there, and then I'm going to put my grouping. Okay. So basically what's happening, let me just make this a little bit bigger so you can see it, is I've got my 12 run numbers and I've got my 4 wafer positions. And what JMP is doing is it's plotting that data on the y-axis. And so this is where you see that bimodal pattern we were seeing in the histograms, right? There's a bunch of points that are low, and there's a bunch of points that are high, and it's minimal inside the center. So we're kind of seeing that relationship. Now, there's something really neat in JMP that allows you to explore data visually very, very quickly. I don't have to go through that process to make a second graph like I did. I can actually do it all from this one report window. Remember, when you run an analysis in JMP, any kind of analysis, whether it's a graph, whether it's a statistical analysis, whether it's a model, this thing here is not a static report. It is an interactive platform. So that's the way I want you to think of using JMP if you haven't used JMP or you're new to JMP. You are launching an interactive platform every time you run some kind of analysis. So what I can do is, and I'm going to drop down this red triangle. These red triangles are everywhere in JMP, and that's how you open up our contextual menus of what you would do next. Well, I'm going to launch something called the column switcher, and what this allows me to do is to choose which variable I want on the y-axis, and I've got 3, right? y1, y2, y3. Click OK, and then now what I have over here is this little controller that allows me just to switch it so I can do it all from one graph. Now, I could have gone and created another graph for y2 and another graph for y3. I'm not saying you would never do that, but I just find it so much easier to just be able to do it from one view. Now, notice as I'm clicking through this, and this is what you're hoping your students start to see, is getting a sense of what the variation is. So when I go to y2, you might look at this and see, okay, these are kind of bouncing around. All right, so I can see certain wafers have very low values, certain wafers have very high values, but I can't quite see if it's systematically with one wafer position or one run number. But now I'm going to go to y3. Okay, now if you look at this, you'll notice, and you're hoping your students notice this as well. Look at all the wafer position 2s. I'll just highlight a couple here so you get the idea. You could keep going, but you see how all the wafer position 2s tend to be large. All the wafer position 3s tend to be low. I could keep going, but you see what's happening right there. And then 2 and 4 are in the middle, but if you look, maybe 4 is a little higher than 2. So you're starting to get a sense of, aha, now for this variable y3, the variation looks like it has something to do with that location of the wafer relative to that grid I showed you at the beginning. I'm going to go back to that diagram right here. Now, how did I create that? I'll show you right now. Well, if you are measuring something that has to do with the location, like in this case, we're measuring on a wafer, I actually recorded the coordinates on where on that wafer it was measured. So that's what these little dots are. So these are showing all the places on the wafer that measurements were made. So you can see going around the edge, and then it gets moving in towards the center, and there's a measurement there at the center. Okay, so if I have this XY coordinate like I do, I can show that diagram. So I'm going to launch JUMP's Graph Builder. So if you haven't used the Graph Builder yet, basically the Graph Builder is the way you make graphs in JUMP. Now, there are graphs everywhere in JUMP. Anytime you do any kind of analysis, whether it's a basic analysis or a sophisticated analysis, we pride ourselves on there's visualizations everywhere. We love that. We think data comes alive when you can see it and interact with it. So even though there are graphs everywhere in JUMP, a lot of times when you're just, hey, I'm making a graph without any specific analysis in mind, you're often launching the Graph Builder. And basically think of the Graph Builder as a blank canvas sitting there waiting for you to build the graph. And it's really nice because you don't have to think ahead of time, oh, I want to make this graph or I want to make this graph. And you have to keep going back and forth, like if you were using open source and you're making dozens and dozens of different graphs to get the one you want. Well, you interactively build it. So if I bring in the XY coordinates here, I'm just putting them in the position. Basically, there is, I'll make this a little small so you can see it as a circle, right? So that's basically what the XY coordinates are. Now, that's just showing where on all the wafers it's being measured, but there are 48 different wafers. So if I bring in wafer position and run number, and then let me just resize this so it makes a nice little circle. That's how I made that diagram. Now, why am I making this diagram? Well, here's what I can do. I'm going to take the outcome variable. I'm going to do it for all of them, but I'll just start off with the first one. And I'm going to drag that variable and put it right here as the color. And so now what JUMP is doing is it's color coding each of those coordinate points based upon the value for that variable. And here I'm looking at Y1. Now, before I interpret Y1, I'm going to bring up that column switcher again and have Y1, Y2, Y3. So over here, I'm going to be able to just swap and look at all of them, but I'm now set up to explore it. Now notice the colors on those wafers. And do you remember Y1? Let me bring that back up. Bring up the histograms. So remember Y1 had that bimodal shape. Well, now if we look at it relative to this diagram here of the wafers, you actually start to see what's happening there. That on the edge of the wafers, now in this color coding, blue, the more blue it is, the lower the values, and the more red it is, the higher values. But you can change that. If you click on this, you can go in here and change color themes. You can even pick a scale, like, oh, I want to put it on the log scale or standard deviation or quantile, and you can pick minimums and stuff. So there's all sorts of things you can do with the colors. I'm just going to leave it as the default. But what you should easily see is the edges of the wafer are where the values are very low. And then as you move in, they start to get higher. And then actually in the center, it kind of goes back down again. So that's that bimodal pattern you're seeing here, that these values that are low. Oh, let me show you this. This is another awesome thing about JUMP. Whenever you interact with one piece of output, it's connected to all the other pieces of output. So watch this as I'm highlighting these points on this histogram. Do you see how they're being highlighted over there in the wafer? So now as I grab all the low values, I can see where they are. And then if I grab all the high values, I can see where they are, right? So now I'm like, aha. So now your students are going to start to see, oh, wait a minute, now I can explain this variation even more. It's the location of the wafer that's happening. Now I'm going to do with Y2. Now, Okay, so see what I'm trying to get at, like, okay, is there something there? Does that just look random? That looks kind of random to me, right? It looks like, well, I guess I should say certain wafers tend to score or have low values, and certain wafers will tend to have high values, but it's not going within inside of a wafer, and it doesn't look like it has anything to do with run number or wafer position. That looks sort of randomly spread. Okay, so now I'm getting at this. I couldn't see this in any other graph so far. It's this graph over here that I'm getting at this. Now let's go to Y3. Let's start highlighting the low values. Look at that. And we saw that in one of the other graphs, that wafer positions, it's like 3 and then 1 tend to score lower. And then if I go to the higher values, see that wafer position 2 tends to have most of the high values, followed by wafer position 4. So this, you can, I hope you're seeing this interactive. I wish they had this when I was in college. Back then I was programming and in SAS, and things were kind of static, but this interactivity is really where I think not only do you find the features in the data, but I think it makes the data come alive, and it gets the students excited about finding and exploring data and finding these patterns. And then you can do a lot of this fun stuff without having to make everything about formulas and equations, right? A lot of things you do out in practice are not formal statistical tested models. A lot of it is trying to visualize the data, trying to explore the data, find the patterns, and tell the story. And I think these graphs that I'm showing here really explain this particular data set really well. Now I'm going to close this up and go to another data set, again, just to try to continue this process. But before I do, Ross, let me just check in to see if anyone has any questions and wants to see anything more about this specific data set.
No, I think we're all caught up on questions, Kevin, so feel free to continue.
Okay, thank you for addressing those as they come up. Okay.
Real quick, actually, one just came in, Kevin. So the question is that the dynamic view is interesting, but how could we render it in a report or video format or something like that to convey it to an audience? Do you have any recommendations?
Yeah, you know what I'll do when I get to another report, I'll show how you can export that as actually an HTML page that you can, so someone can look at that data and in certain cases interact with it without actually having JMP software.
Great. And when you're showing any of that, do you plan to show maybe how to export these to something like PowerPoint as well? We just got a question about PowerPoint and also LaTeX.
Okay, you know what I'll do is I'll do that together. But I'm going to ask you, Ross, are you familiar with exporting it into a LaTeX environment?
I personally have not done that before.
Okay, yeah, I haven't either, but you know what we'll do is we'll have to get back to the person that asked that question.
Sure, no problem. And then the last question before we move on, just a quick question on how the type of interactive graphing that you just showed would perform when we're dealing with really high dimensional data set, for example, in gene expression.
Yeah, I would say that's really where it's very beneficial, right? Because the more complex the data is, the more highly dimensional the data is, I think the formal statistical test and what analysis you should do is even harder. So I think highly dimensional data is perfect applications for this visual exploration. JMP can handle millions and millions of data points, right? So there's no really limitation in JMP, but because JMP is running locally on your machine, really the limitation is based upon your computer, right? How much memory you have and how fast it can process data. But JMP itself doesn't have any limitations. So if you have what's classic in gene expression data, is it's not uncommon to say, I got 200,000 rows and 800 observations in each variable, and you have a very, very large data set. JMP can handle that, no problem. But again, it might run slow or take some time just because of the nature of your machine, but not JMP, the software itself.
All right, thanks, Kevin. I think we're all caught up.
Okay, perfect. Now I'm going to open up this data set, but before I do, I want to mention something that's going to happen shortly. So I don't know if, hold on, let me open up this other page first. I don't know if any of you have taken advantage of our case studies. I'm going to open up our case study library here, and I'm going to paste this into the chat. So we have, as part of our teaching and learning resources, a collection of case studies, and I think there's over 60. I'm just scrolling. I know I'm scrolling really fast. I just wanted to get to the bottom here to see how many we have. Okay, we have 60 posted right now. There's some more we're currently working on, so we're always adding to this. But basically, we have this collection of case studies, and you'll see that we're describing the statistical tools you're going to use and what field and subject it is. So I'm just going to pick one. And since we're talking about visualization, I'll pick one of these early ones that don't deal with any statistical analyses formally, but just visualizations. Oh, and by the way, these are made by collaboration with professors and industry people. Okay, so these would be your peers and also folks out in industry. So I'm just going to go to one of them here, and you can download these case studies, and basically what they are is a scenario. There'll be a storyline. There's a data set. We describe what the data is about, what the objectives of the analysis are about, and then we step through some analyses. So it's trying to motivate why you're doing a particular analysis. It gives the JUMP instructions on doing that particular analysis, and then it interprets the results. Okay? I know I'm scrolling fast. I don't want to read this. I just want to scan through here so you can see what it's about. So the case study demonstrates a bunch of analyses. It teaches some concepts. And then when it gets to the end, and I'll scroll to the end here. When it gets to the very end, you can see here we're giving some interpretation of the results from a business perspective in this case. And then there'll be some exercises. And either it's a continuation of working with the same data set, or it's another data set and you're going to do similar analyses. So these are great because you can demonstrate in class or have the students go through this on their own, and then maybe assign these as team projects or as a final capstone assignment for a course. And so we have over 60 of these, and I said we add these up constantly. So you'll see more every time you go back, and hopefully we're covering all sorts of applications: engineering, science, social sciences, business, marketing. Pretty good coverage. Now, I'm showing you those first, but what I'm doing with this is another type of resource we're about to put up shortly, should be there in the next month or so, is we're calling them enhanced data sets. And it's similar to the case study in the sense of there's a description of what statistical tools and what JUMP tools you'll be using. This one happens to be about homelessness, which is a topic that we're all aware of. It's been in the news quite a bit, especially in urban areas. So there's a problem statement, there's a description of why it's important to look at this data. And this set, in this case, we have a whole bunch of variables in this data set, which I'm going to go to in a moment. And what makes these different than the case studies is there isn't that demonstration part. It goes right to the exercises. So again, these are great to give out as assignments or team projects in class, or a final capstone project. And there's a set of exercise posing a question. There's also some hints in there to help the students along if you feel necessary. Some of these will actually come with some complementary material. So to give a little bit more context, in this particular one, there's actually a report that comes out annually that's put out by HUD, Housing and Urban Development. And if you want, you can direct your students to this report to give them a little context of, hey, this is why it's important to look at this kind of data. And these are, let's take a moment for the page to unload. So this is a report that HUD does for Congress to give a summary of what's happening with homelessness across the US. So a lot of these will have some of that complementary material. In this case, it also shows where you get the data. And if you went to that link, you would see there's even more data. So it even allows you to expand beyond what we're doing here. But okay, sorry, that was a little bit of a lengthy setup, but just wanting you to know about those resources, case studies, and then what's coming shortly is these enhanced data sets if you're not aware. Okay, so what is this data set about? Well, it's about homelessness, and you'll see that we have, I'll use the column header again. So we've got data going back to 2013 all the way to 2022. And we have homelessness information on every state. So you can see we've got all the US states, including the District of Columbia. And we have things like, okay, what's the count of the overall homelessness? And then overall homelessness for certain age groups. So you see we have under 18, 18 to 24, over 24. Then we have information about the count of the number of homeless that are sheltered versus unsheltered. And then variables like, oh, maybe we can look at percent homeless that are sheltered. Now, in this particular exercise, an enhanced case study, enhanced data set, if you went to the exercises, you would see that one of the steps in the exercise is to actually turn this information into per capita, which would obviously be something you would do. So we actually have the population of each of the states. I'm not going to do that here, but just wanting, that's part of this particular enhanced data set. Hey, it would make sense if we looked at this per capita, not just total. But I just want to show a few graphical tools. Well, when you have geographic data like we have here, states, well, if I open up the graph builder and I bring in states and I just drag it into the center of the graph, well, JMP recognizes those are the names of states. So, well, you must want a graph of a map of the United States. So it's going to do that automatically. This would work even if you had counties. So you could, if you're zoomed in, say the counties of a particular state, you can get a county map. You can get a world map. Here we just have the US. Now the map by itself isn't that helpful. We got to start bringing in these variables. So if I grab one of these, I'm just going to grab overall homelessness. And I'm going to put it on the color variable. This is very similar to the semiconductor example. Now, this is overall homelessness. So obviously states that have a very large population like California, New York, and even Texas, well, those are going to have high homelessness numbers because, well, those are very large states. So this is motivating. And if you went through these exercises, you would see this. It motivates why it's probably better to look at this per capita. But what I'm going to do is I'm going to change. I mentioned you can change these. I mentioned that you can change the scale over here. So what I'm going to do is I'm going to put this on a standard deviation scale. So now what it's going to do is hit OK. So now it's putting it on, well, if it's at the mean or close to the mean, then it's going to be gray. And then as you move off plus or minus number of standard deviation, it's going to change the color. Now, again, I know per capita would be better here, but I just making graph wanting to show you this. And just like I did, I can bring up the column switcher and decide, well, maybe I want to look at every possible variable. Oh, the last one, I do actually have a per capita I see at the very end here. Hit OK. And then now I can just click through and move through every variable I want. It's going to probably make the most sense when I get to the, there's percent shelter. That's kind of an interesting thing to look at. And here's the overall homelessness per capita. Now, I like data sets like this because it's not as if I need to do a statistical test. And even then, I don't know if that would make sense. I think just looking at it and graphing the data is where you're going to see features that you're looking for, like which states tend to have a very large number of homelessness or based upon different age groups or sheltered. And I can do that all from a map. You know, I don't know how many variables, but I have there 4, 6, 8, 10, 12, 14, 16. I got 17. And then if I did per capita for all these others, you know, then it would be probably, 25, 30. So I can do all of that exploration from one map like I just did there. Okay, now I'm going to close this and I want to see. Oh, actually, this is a good one. So I did this the same way, where I basically just put in the per capita homelessness, got a map. But what I did is I brought up something called the data filter. And the way you do that is under the red triangle. I'm going to remove it so I can make it again. If I go under the red triangle, say local data filter, I can pick a variable, and I'm going to pick year just to illustrate it. Now what I can do is say, okay, show me this data for each year individually. And so now I can just click through and see what the values are for each year. So now it's a way I can look at some trends and see if things are changing for certain states over time. And then this is overall homelessness, but again, I could also bring up that column switcher again and bring in all the variables. So if I did that, now I can filter and switch variables all from one report window, as opposed to having to create a different one for every combination. I mean, if you think about that, if I have 24 variables and I've got all of these states, think of every combination of graphs. If I was looking at every combination of year and variable, how many maps I would have. Much more easy to explore the data if you can do it all from one graph like I'm doing here. I'm going to show one other thing if I have it here. Oh yeah, this will be a fun one. I don't think I have already made it. No, I'm going to make something called the bubble plot. And what I'm going to do is I'll just do this for one of these. So I'm going to go overall homelessness. And then I'm going to go sheltered homeless. And I'm going to pick HUD region and state. So HUD regions are groups of states. So there is, I'm trying to remember how many HUD regions there are. It looks like there's 10 HUD regions. So they're just groups of states, right? So, and they tend to be like New England or the Southeast. So I'm going to put that as the ID variable. Now year is the time variable. And I'm going to make population the size of the bubble. I could also pick a variable for the color of the bubble. And just to do something, I'm going to pick the per capita homeless rate there. Click OK. Now I'm going to do a few things before I get going here. And what I'm going to do is I'm going to add trail lines. And I'm going to add labels. Okay, so right now, these are just as the HUD region. Okay, so here's HUD region 2. And so if I go back here, what's HUD region 2? HUD region 2 is, I can see it's New York, New Jersey. If that could be it. Nope, yeah, looks like that's it. Okay. Now I can hit play and I can watch the movement of those two variables as time goes on. Okay, this is kind of very interesting as you see the changes. Now, something I can do in here, which is even more interesting, if I grab a HUD region, so I'm just going to highlight that one right there. See how that's highlighted? Watch this. I'm going to hit this button called split. I'll wait till it comes around again. Split, and now it's pulling out the states combined. I can bring that together, split. See how it's pulling out the states. So this one's California, Arizona, Nevada. You can see how large California is. Again, now this is not a per capita. The color is per capita, but the location on this this bubble plot, this scatter plot, I should say this interactive motion scatter plot. Now, I don't know if everybody's seeing that around 2021, the numbers drop dramatically. Watch this here. Right, so you're seeing that change. Well, what's happening is, see how that just bounced right down into what's happening. Let me zoom this back so I can have it in the farther scale here. Well, if you went to that supplementary material and looked at the report, it turned out that it was very difficult to get counts during that time period, and we all know why, right? We're all aware of what was happening with COVID during that time. And so it was very difficult to go get accurate counts. And these are the kinds of things you're hoping your students see, because this is the real world, right? They have to sort of look at data, see some feature in the data and think, well, why could that be? It would be incorrect to think all of a sudden the homelessness dropped that much. that would be sort of strange. We have to find a reason. How could that have happened? But with a little bit of thought, you can realize, oh, wait a minute, maybe that data for that year was not accurate to use because we don't have good counts during that time. So I'm just showing this as a way so you can see a way you can see how I think. Well, I don't even know what statistical test you would do here. Actually, what I'm going to pull out all the states just so you can see it. Now we can see it kind of with all the states moving. Oh, you know what I can even do too? I'm going to bring up the data filter. I'm going to bring up HUD region and state. Now what this is actually a good idea. Now I can hone in on certain states. So if I wanted to, for example, say, okay, let's just pick Georgia, Florida, and I'm going to pick a couple states in the southeast there, Louisiana. And so now I'm just looking at individual states. So now I can use this data filter to just pick specific states or maybe specific HUD regions. And I can do all of this from one graph as opposed to having to make separate graphs for every analysis I could think of or everything I want to look at. Now, what I'm going to do is I am going to export this. And I can decide, well, this is probably a good one for, oh, I don't know if I have this set up correctly yet. We'll find out in a second. Apologize if I don't here. Okay, so I just sent that to a web page here. Okay, so now what I'm moving around right there, this isn't JMP, right? I'm on a web page that was set up, but notice I can now play that and watch that motion. So now I can look at this from outside of JMP environment, which out in the real world, that's probably common, right? The analysts are going to have a certain set of tools, and then they have to provide analysis results to people that are not going to have those same tools. And so something like this makes it easy to share. Now, I'm not going to show the PowerPoint one with this particular graph. I'm going to do it with a different one in a moment. So I'm going to close this one up. Let me pick a different data set here. So this data set, and this happens to be another one. This happens to be another one that's an enhanced data set, and this is about marathon runners' performance. And so if you use this enhanced data set, again, there's a storyline or motivation of why you would look at this data, and then a whole bunch of exercise that are stepping students through what kind of analyses you would run and what kind of questions these analyses can address. And so let me open up the data. Okay. Now, all that we have here is the time for each of these runners. So there's over 26,000, almost 26,600 runners we have here. And we have their time at different points in the race, like at the 5K mark, at the 10K mark, the 15K mark, the half marathon mark, the full marathon mark. We have their average run rates, their pace. These other variables are ones I created where I just were subtracting, like, so I could get their time at, say for the first half or the second half. So now I've got sort of the time that has passed in between different marks. These aren't in the original data set. I'm creating these, but again, that's kind of the stuff that happens in practice. You get a particular data set, but you might have to create other things. Just like the homelessness data set, you have to think, oh, I got to create new variables per capita, because that would be a more logical way to look at the data. Okay. Now with that, I also have the age of the runners and their sex. Okay, so now a typical problem in industry is management would know, hey, we have all this data. We have a big database of customer data or whatever it is. They will often not have a specific analysis in mind or a specific question in mind. They just, someone who has knowledge of working with data, we have all this customer data, go open it up and see what you can find. Sometimes it's that vague, like what insights about our customers can you gain from looking at the data? That's the extent sometimes of the description. Okay? It's that simple. And then you as an analyst have to, okay, well, let me start doing it. And I think exploratory data analysis is perfect for that, because you don't have to think about a specific model or a hypothesis. You just visualize and graph the data and see what features I find. So just for preservation of time, I'm just going to open up some of these I've already made. But for example, this is using the distribution platform I showed you. So this is just summarizing each of these variables with histograms. And so I can kind of see the shape. I can identify, in this case, runners that have very large or small values compared to the rest of the runners. And so just from that, I might gain a lot. Here's a graph where I just plotted their final time of running the race against their placement. Now that is obviously a continuous function, right? That there's no variation here, because obviously the lower your time is, you're going to place earlier, and the higher your time is, you're going to place, right? So there's a perfect relationship there. But it's interesting to see that those early placement, how close that they are, as that runtime is kind of squeezed tight together there, and then over here is the towards the end, right? So you can see that spread, that as you go from runner 1 to 2 to 2 to 3 to 3 to 4, those differences are much larger than when you're in the middle. So this shape gives you some description of, okay, this is what happens when runners do that. I'm just looking at the left side colored dots next to each record. I'm looking at this question, Ross, about right here, I have in the data table, I have all of the males are using a blue dot, and all of the females are using a purple dot. Okay. Now, even though you can do that once you're at the graph stage, another thing you can do is, before that, if I go rows, and I could say color or mark by column, and then I pick a column like, say, sex, and then now I can go in here and change it. So I can pick whatever color I want. I could also pick whatever symbol I want. When you do that, which I had already done, then I have these row states set up so that any analysis I do going forward is going to use that color coding or marker coding that I chose. And so in this case, I chose males blue and females purple. So again, any graph you make going forward. I'm just going to open up a couple of these graphs. So here's one where I put placement on the x-axis, and I put the time on the y-axis. In this case, I started off with the 5K time. And I've shown this already, is I just set up the column switcher. So now I can pick any variable I want and plot that on the y-axis. I can also, right now it's plotting both males and females, but I can also choose to just look at one at a time if I wish, or look at them both like I'm doing there. And something like this, if students were making these graphs, what I've noticed people tend to do, and I do this in practice as well, is you start to identify the ones that kind of stand out, and you can even, if you highlight data like I just did, watch this, I'm just going to highlight a couple. Those points I'm going to see across every graph. They're highlighted. Oh, look at how far that is up there. And that's the distance between the 10K and 5K time. So that runner, think how slow that runner did during that particular window of time. And I can click around. Oh, and what's interesting is you'll see in this particular data set how a particular runner will run really fast on one part of the race and then run really slow on another part of the race, and that kind of will show where it lands overall. Now, I don't know what formal statistical analysis would make sense here. So I can't think of what that would be, but I certainly can make all sorts of different graphs. Here's one where I'm looking at the placement versus the the second half of the marathon time, right? Seeing that kind of shape, again, looking for unusual runners here, looking at it relative to placement. Look at how much variation you see when it comes to the runners at the end. I mean, they really slow down quite a bit from the second half to the first half. They really run that second half much slower. Where if you look at runners at the beginning, that differential is less. Now, I found Ross, I have to admit, when I decided, okay, I'll do this webinar, I thought what's hard about this particular webinar is it's unfair that I only get an hour, because exploratory data analysis, I think with JUMP is, I mean, it just really highlights the power of JUMP because of this interactivity with graphs. So in this time, I was only able to open up a few data sets and just show you a few things, but I strongly encourage you to go to our webinar library. And I'll post that link up in it because I'm just typing it in, Ross. We have lots of other recorded webinars on exploring data, creating graphs, visualizations. And so this 55 minutes I just spent is not all doing it any justice of how much you can do with JUMP. So I just put the link to our academic webinar library there. I encourage you to go there. We have a whole collection of other webinars on, I'm just kind of showing the page right here, cleaning and preparing data for analysis, data exploration, data visualization, creating publication quality graphics, of course, a lot of formal statistical techniques. But I think when you go through some of these other webinars, and then of course the one I just did, you will really see that it's almost as if JUMP was built for the way people explore data and analyze data in practice, because of that interactive nature to it, how one analysis leads to a set of results and a set of tools, which leads you to the next one and the next one and so on. And I think it's one of those tools where you can sort of kind of leave an open-ended question for the student and say, hey, here's a data set, just have at it, dig into it, try to create different visualizations, see what features you can pull out of the data, and then tell a story with it. I think JUMP stands out from all the other software and certainly open source environments when it comes to this. And again, I wish I had a couple more hours. That'd force you to listen for a couple more hours, but there's just so much to show. I feel bad that I can only show a few things. But with that, Ross, let's see if there's any questions that are outstanding.
Sure. Thanks, Kevin. Before we address, there's at least one question outstanding. I would just second exactly what you just said. It was almost an impossible task trying to, do a sweeping review of exploratory tools in JUMP. But I think we saw a lot of great things today that really give us an idea of what's possible. And then that plus the creativity of all the instructors and other folks on this webinar, I think could probably create some experiences for students that'll do a lot of good. We have a lot of interest in the enhanced data sets that you showed. One of the outstanding questions that I think is particularly relevant is to what degree the enhanced data sets are cleaned already. So that is checked for data accuracy, completeness, etc. Or are there some enhanced data sets that will actually make for good practice cleaning data as well?
I think all of them, nothing's coming to mind of something that has to be cleaned. I think they're all ready to go. There's no issues or errors. There are, however, things you would do, like the example of the homelessness was a perfect one, where you're like, oh, I need to, actually the marathon one was too. Oh, I want to create new variables, like the per capita would make sense for the homelessness data set. And then in the marathon data set, it was, oh, let me look at differentials. So the data just came with the 5K mark, 10K mark, the half, marathon. And then it takes to the analyst to like, oh, let me look at the difference between this time and this time or this time and this time. So the enhanced data sets do have those kinds of steps where you create new variables to help with the analysis. But none of the ones that I've made so far have an actual problem with the data. There's nothing wrong with the data.
All right, thank you for that. Another question that just came in, maybe you can comment on it briefly. How about data visualization tools when you're working specifically with text data? And I imagine this individual specifically means unstructured text.
Yes, of course. So I don't know if you've used Jump's Text Explorer before. While I'm talking, I'm finding the data set that I just want to pull open real fast. One moment. So I'm just opening a data set. It happens to be about a survey that was done in Toronto to see what the population thought about the city opening up a casino. So I'm not going to go into much detail, but the point is the data that we want to analyze is this unstructured data here. So basically each respondent is telling whether they are opposed or in favor of it and what their reasons for it. So if you look at this column highlighting, you can see there's some people think it's good for economic development and they're in favor of it, and other people think it will bring problems like gambling and drug addiction and stuff, and they think negative. But I'm opening up this data set just to quickly show you that we have a tool called Text Explorer. And if you go to our webinar library, that link I provided, we have actually webinars on this specific topic. But what I'm going to do is I'm just going to run a quick analysis here, run the Text Explorer on that data. And so what it's just doing is just counting the number of times different words are in phrases are used. There's a lot of cleanup you would do here. I'm not going to do it, but one of the most popular visualizations that are done with Text Explorer is this word cloud. And so it's basically showing all the words, and then just the size of the word is based upon the frequency of that word being used. The default is to display it like this, but I can go in there and do things like, well, let me center it. That's a common way. You're probably used to seeing it that way. I can also choose to color it. So I can say, well, why don't we color this? I can pick just sort of some arbitrary colors, right? That's just to, I guess, make it a little bit more visually appealing. But what might be more informative is to color it by a value. And I could choose something like, where do I have this? Oh, I could do, let me color it by, I was going to do, maybe it's going to, yeah, there we go. So now I just colored it by age. And so now it's taking all the people say that said the word city or said the word gambling or whatever these words are, and then takes a look at all of their ages and then averages it together and color codes it according to that. So this is a nice little visualization that's really fun for Text Explorer.
Great, thanks, Kevin.
Oh, sorry, go ahead, Ross.
Oh, no, that's it. I was just going to say, I think we have addressed all the outstanding questions.